In previous parts of this tutorial, we looked at the calculations and forming the involute on sheet form. Now we're going to start putting together an active working spur gear in CAD. So here I'm just drawing some of the critical circles that are going to form our shape. So this is the pitch circle I'm going to put in. Let's just give it an arbitrary figure. This is all going to change in a little while. This is basically a template sketch that we're forming at the moment. So the addendum circle, and we'll give this an arbitrary value. This gear is going to be equation driven, so when we're finished we can modify certain variables and have the whole gear change, and we'll finish by animating the gear or a couple of gears interacting. So now the root circle, again give it an arbitrary value. And now the base circle. So we've explained what all these, this is the clearance circle, sorry, not the base circle. We've explained what all of these circles are in a previous video and how critical they are to the spur gear design. So here, this one is the base circle. Okay, so this is going to be equation driven. We've completed our first template sketch, so now we can go into the equations toolbar, but first we've got to unhide it. So equations, show file properties. Oh, let's try that again. Equations can be tricky. Show file properties. Okay, so here's equations. Right click, manage equations. Let's bring them on the screen. So everything we've labelled up so far with a dimension is shown in the dimension section. We need some global variables though. So we're going to put in the module. This is something that we're going to change time and time again. And the number of teeth, this is also critical. This is all going to drive how this gear forms. And the pressure angle. And the pressure angle being between 15 and 25 degrees depending on the gear we produce. Okay, so we've kind of set our base template for this gear. We now need to start linking and making equations. So the pitch circle is module times number of teeth. The addendum circle is the pitch circle plus the module times 2, sorry. Now the root circle, or even the clearance. Let's try the clearance circle first. And this is the pitch circle minus the module times 2. Now the root circle. So the root circle is the absolute base of the gear tooth, ensuring that the meshing gear doesn't ever meet this face. So the clearance circles basically is where the interacting face of the mating gear reaches. It never makes it as far as the root circle. Okay, so the base circle is pitch circle cos pressure angle, or cosine pressure angle. Okay, so we've put together some basic equations here. Let's accept that, and then we can continue. Let's just rename this briefly. I'm building this this gear using a series of template sketches, but you might want to do everything in one sketch. I'm just doing it this way for ease of showing you how this works. Okay, let's now start forming the involute curve that we're going to use to form our gear tooth profile. So a new template sketch on the same plane. Give ourselves some reference geometry to start working with. I'm not going to form an entire involute. We don't need the whole thing. I'm just going to form across 90 degrees. If you feel more comfortable, you might want to go for a full 360 degree curve, but I just need my 4 references to form this. So let's just make sure all my reference geometry is constrained. Okay. So I'm just drawing an arbitrary figure at 90 degrees. Okay, so these dimensions have all populated the equations menu. So the array is the 4 lines we've just drawn. So if we ever need to change this is here. We're never going to need to change this, but just in case we do, it's good practice to label everything. So this dimension is interesting and is helpful in forming the involute. So this dimension will change actually as if when this model is finished. If you were to change the module and the number of teeth, the base circle, quarter, circumference, length dimension will change as the gear shrinks and grows. So it's important that this one is equation driven. So to make this change, we need to take the base circle. We need to know the circumference, so diameter times pi, and because we only need a quarter, over 4. That will give us a quarter of the circumference. So when we go back into the sketch, 44.28, that is a quarter of the circumference of the base circle. Okay. So we've got our first reference line. Let's draw a second one, a third one. Okay. So now we only need 2/3 of the circumference at the second reference and 1/3 of the quarter here to form the involute. So we can derive this through an equation. So this line is going to equal this driven equation divided by 3 times 2. I know there are other ways of doing this, but it's a fairly easy way of explaining it. And then this dimension is going to be the base circle quarter circumference divided by 3. So we know, so if we wrapped around, we'd have these equal sections. So now we can form the involute from a reference point to our second, to our third, to our fourth, and we'll stop there. So we basically cut our circumference into 3 sections. We've made tangents and we formed our involute circle. So let's just make everything here into construction geometry apart from the involute. And that is the beginning of our involute for our gear tooth profile. Right, now let's form our gear tooth. So we've got our involute template sketched, and when we've got our ordinary template sketch, we're going to go into the involute. So we need to put in some more reference geometry. We're now going to work out what our pitch circle is, which is critical to working out where to place our next involute circle. So just turning some of the geometry into construction geometry. Okay, so this angle will become our pitch circle. It's not 20 degrees, it's just set to 20 at the moment. So let's just work out what that is. So relabel it pitch circle, so it's going to show up in the equations toolbar or equations menu. Circular pitch, not pitch circle. So this is 360 degrees divided by the number of teeth, and that will give us our circular pitch. So we now need to divide this in half. So I'm just using this central line. Let's just make sure everything connects. Okay, just to show the circular pitch is now shown in the equations list. So into the involute sketch, we need to divide this line up. So I'm going to trim it, get rid of the geometry I don't want. Another reference line. Okay, and this can be our mirror face for forming the second involute curve. So we're going to mirror this spline about this center mark, and the gear tooth is forming. So let's bring back the previous template so you can see how it's forming around the circles. So we can start trimming this up now to form the gear tooth. So the first 2 sketches I've used as reference geometry. This third sketch I'm going to use to actually form the tooth. So because we use splines, and in SolidWorks splines can sometimes be a bit tricky to work with, I'm going to trace a curve directly over the spline. And this is because when I was working out how to make this video, this this is where it generally went wrong, if it was going to go wrong in the practice sessions. So using a curve, a formed curve, as opposed to a spline, just kind of like stops those error messages from creeping in. So I'm just mating the geometry I want. You might say forming the curves kind of invalidates the involute, but it's good for this for the CAD representation, and you'll see at the end that SolidWorks will actually animate the gears. So let's just get rid of the geometry we don't want. We're just trimming it away. Once things are going to start losing constraints now, but we can add things back in. So let's just get rid of all the reference geometry that's not needed. Okay. Yep, and as you can see, it's we're no longer fully constrained, but we can bring back our hidden template sketches and reconstrain. And of course these template sketches are all equation driven, so they're going to grow and shrink with the gear. So just constraining. Want everything to go black again. Just good practice. And of course, unless we're fully constrained, we're never going to be able to control this gear. Okay, so everything's black again. Good. Okay, so we've got the geometry we want. So 3 sketches. You might want to do this in one, but I found it easiest to do this in a series of sketches and use the 2 templates to drive the gearing. So a boss extrude of the gear, single tooth, let's just see what's gone wrong. So we've just lost one of the mates, we're over constrained, so let's just remove anything that's over constraining. I want it to all be nice and fully constrained appropriately. I'd better get this right now, otherwise it's going to cause headaches later on. So we're just going to, let's just find where this is going wrong, delete the mates that we don't like. Who says things always go perfectly in tutorials? Okay, so here we are, fully constrained. Okay, hopefully we come out and the error goes. Nope, no errors. Nice and clean. Okay, a clean extrude. And then we can circular pattern. So the center point is the center point of the circle. Let's put some reference geometry in first. Let's put an axis in, because we can use this axis time and time again when we're pulling this gear into other models. So an axis around about the origin point and the front face. Okay, let's make this circular pattern. Right, so the axis, let's use that. And this is the feature. An arbitrary value at the moment for the number of points. Okay, this didn't work. Let's find out what went wrong. I'm showing you the good and the bad in this tutorial. So turning off the propagate, it's disjointed. I can see what's gone wrong. We're arraying a feature. We shouldn't be arraying a feature. Nothing wrong with the extrude. Let's go back into circular pattern, or even delete it and start again. Okay, so let's try again. So this time we're going to use bodies. So what we did wrong is we tried to make a feature pattern. We should have made an array of the bodies. Okay, so an arbitrary number of bodies, but we can make this equation driven as well. So getting rid of everything that we don't want, go into the equations, manage the equations. So the circular pattern right at the bottom, 20. So this is now going to equal the number of teeth. Okay. Right, so there are other ways of doing this. I've decided to model the gear teeth, and then I'm going to put the body in as well and merge everything. But you could do everything in one go if you want. So just to finish the gear, so we've got our module. Let's just show, if we change the module, the size of the gear changes. Module 4 or module 2. And everything changes. It's not fallen over so far, which is good. So a nice robust equation driven gear. Not finished. You might be wondering where the middle is. We'll put that back in a minute. So the pressure angle is essential. Okay, so I'm just testing it out. It seems to be working quite well. Okay, right, so now we need to add the middle. So just a simple boss extrude. We're going to use the same front plane. If you want to make your gear fancy, you can. So let's just turn on one of our template sketches, and we want the innermost circle. Let's make it merge. Let's go up to the surface. And it merges. So it's merged. So it's this. So we now just have one solid body. Hide everything that we don't need. And here is our finished gear, or our finished gear template. Right, so let's go into equations. Let's make sure that it still functions. So let's fiddle with the number of teeth, 30. And this error occurred because the module and the number of teeth will not work with the pressure angle, so we need to change the pressure angle. And I can see something's not quite worked out over here, so let's go and have a look at that. This is why it's so important to check to make sure everything works. Right, so we've merged the result, but we need to merge with all bodies, so select that option. So merging with all bodies now means that when we edit from this point on, so we can't go back to 25 degrees because we already were there before, you're going to see this error time and time again. It's a key indicator that what you're putting in doesn't compute. So 15 degrees. Change the module to 4. Let's bring that back. Change this to 2. Change this to 20. Okay, so a pretty robust gear template. And now we can try and animate. Okay, let's now try animating the gears. So here are 2 gear templates that I've already pre-assembled. We've used a series of mates, including the tangent mate, which binds the pitch circles, and a gear mate. Now the gear mate, if we look at, represents the ratio. So 20-40, or 1:2. We have 20 teeth in the blue gear and 40 teeth in the green gear. So let's just look at the blue gear. In the equations, 20 teeth with a pressure angle of 20 and a module of 2. Let's look at the green gear. Up to the equation, number of teeth 40, pressure angle exactly the same, and the module is exactly the same. So just set up a basic motion assembly or basic motion study. We're using a rotary motor, constant speed of 20 RPM at the moment. Might need to slow that down. Let's run it. Yes, very fast, but the gears are meshing. Okay, so let's just bring that back, slow it down a little bit. 10 RPM. And run it, and it seems to work fine. Okay, right, now let's just modify these gears slightly, just to show you that it still runs when we modify the equations. So 25 teeth, change the module to 1, and let's try changing these. Let's say 50. Okay, so we don't like the pressure angle, so let's just change the module. It still doesn't like the pressure angle, so the pressure angle, let's change it to 15 degrees, and now it computes. So now we're going to have to go back to the blue gear and change the pressure angle to match. Otherwise it's not going to work. So identical. Right, so now let's go, yeah, so let's go back to the assembly. Everything's going to need to rebuild. The mates, as is traditional in SolidWorks, throw themselves out of alignment. $25.50 sounds like we've got the same ratio. Let's make it a little bit more complicated. Let's make it 55. 25.55. So let's just go straight back into this gear and add an extra 5 teeth. Otherwise there'd be no difference. Okay. Yep, the motion study has been thrown by the change. So let's just get everything back to where it should be, because it's still confused between the previous analysis and the current one that we're looking to run. So let's just get everything in position and then put everything back to the start position. Should have put it back to the start position before we moved everything around. Turn the mates off. reposition. And run it a second time. And there you can see it run. So let's just get a bit closer, and you can see the gear mesh continues to run. And that's the end of the Spur gear design tutorial. I hope you liked it.